everyone, welcome to my channel. In the last video we saw about the Destined Laboratory module. Today in this video we are going to see about the next module, made for external storage, the ESP1. The first of the three ESPs. Let's start the video. The External Storage Platform 1. The International Space Station's ESP1 is like a toolbox a mechanic uses to store his equipments. Just as a mechanic uses his toolbox to store his tools and equipment so that he can easily grab them, astronauts use ESP1 to store spare parts for ISS. ESP1 is attached to the outside of the space station, just like a toolbox meant to be kept on a workbench. When something on the space station breaks, astronauts can quickly get the parts they need from the ESP1. This helps them fix things fast, just like a mechanic can quickly find a wrench or a screwdriver in a toolbox to keep everything working. The External Storage Platform 1 ESP1 acts as an external pallet made of steel, specifically designed to accommodate spare parts known as Orbital Replacement Units (ORUs). Unlike pressurized compartments within the ISS, ESP1 itself is not pressurized. However, it requires electricity to power heaters for certain equipment stored on it. ESP1 is equipped with two attachment points where ORUs are securely stored. Although smaller in size compared to other external storage platforms like ESP2 and 3, ESP1 plays a crucial role in providing external storage for vital spare parts necessary for the ISS's functionality and maintenance during space missions. The ESP1's installation to the ISS represents a significant improvement in the space station's logistics and maintenance, contributing significantly to the station's capabilities and resilience in the harsh environment of space. Manufacturer. The ESP1 as part of the International Space Station ISS program was manufactured by various entities including NASA, Boeing and other space agencies and contractors. NASA as a lead agency for the ISS oversaw the project's development and integration. Boeing, a major aerospace manufacturer and contractor for NASA, played a significant role in fabricating and assembling ESP1. This partnership underscores the collective effort and expertise from multiple organizations to design, build and deploy critical infrastructure like ESP1, supporting the ISS's functionality and ongoing scientific research in space. Launch of ESP1. The External Storage Platform 1 ESP1 was launched as part of the STS-102 mission about the Space Shuttle Discovery. During the STS-102 mission, also known as ISS Assembly Mission 5A.1, the launch took place on March 8, 2001 from NASA's Kennedy Space Center in Florida. The Space Shuttle Discovery was chosen as a launch vehicle for this mission, utilizing its capabilities to transport ESP1 to its designated location on the International Space Station ISS. The STS-102 crew consisted of Commander James Wortherby, Pilot James Kelly, and mission specialists Andrew Thomas and Paul Richards. Additionally, it included returning ISS Expedition 1 crew members William Shepard, Yuri Gitzenko, and Sergei Krikavil, who are ending their stay on the International Space Station, and incoming Expedition 2 crew members Yuri Sasho, James Voss, and Susan Helms, who are beginning their mission on the ISS. Docking and attachment of ESP1. Now let's break down every step from approach to docking of STS-102 mission, attaching the ESP1 and landing Shuttle Discovery back to Earth. Before we get into that, let's first see about the two pivotal components that played a crucial role in the attachment of the ESP1. First, the pressurized mating adapter facilitating the docking of the Space Shuttle Discovery. The PMA-2 or 3 is used in all space shuttle missions as an adapter to facilitate connection between the ODS in the space shuttle which utilized the APAS 95 and the common berthing mechanism featured in most of the US orbital segment. And now the second pivotal component, the Shuttle Remote Manipulator System SRMS or Canadarm, used for retrieving and attaching the ESP-1 to the ISS and for other EVAs. The SRMS is another common part of the Space Shuttle used for the attachment of modules until the arriving of Canadarm2. After launch, the Space Shuttle Discovery carrying the ESP-1 opened its cargo bay doors and made its approach to the International Space Station's pressurized mating adapter 2 on the forward CBM of Destiny, and then docked. Then astronauts from inside and outside the Space Shuttle work together to move the ESP-1 from its cargo bay to the internet attachment location on the ISS. Alongside ESP-1, the Space Shuttle Discovery carried the Leonardo module MPLM, an Italian-built cargo module for cargo resupply missions to the ISS. Following the attachment of ESP-1, the crew utilized the Canadarm and robotic systems to transfer cargo from the Leonardo module to the ISS. This process involved carefully unloading and transferring supplies, equipment, and scientific payloads from the Leonardo module to designated locations within the ISS. EVA-1 conducted by astronauts Susan Helms and James Voss, lasting 8 hours and 56 minutes on March 11, 2001, focused on assembling and maintaining the International Space Station ISS. The astronauts connected power and data cables, preparing the pressurized mating adapter 3 for relocation. And set up various pieces of equipment to enhance the space station's functionality. These tasks were crucial for the successful integration of new components and ensure the station's systems were operational. EVA-2 on March 13, 2001, conducted by astronauts Andrew S. W. Thomas and Paul W. Richards, lasted 6 hours and 21 minutes. And aimed to complete the tasks initiated during EVA-1 and further prepare the ISS for future expansions. Then astronauts inside the shuttle's aft flight deck retrieved the ESP-1 from the cargo bay and moved it towards its internet attachment location, which was a trunnion pin located at the port side of Destiny Laboratory using a series of maneuvers by the SRMS. Helms and Voss installed exterior equipment like handrails and communication antenna and performed essential maintenance. Additionally, they set up connectors and fixtures for upcoming module installation. These spacewalks were vital for the ongoing construction and maintenance of the ISS, showcasing the astronauts' technical skills and contributing significantly to the station's development. Launched on 8 March 2001, Discovery undocked from the International Space Station on March 19, 2001, beginning its journey back to Earth. The shuttle re-entered Earth's atmosphere and landed on Kennedy Space Center, Florida, on March 21, 2001 at 2:31 AM EST, Eastern Standard Time. This marked the successful conclusion of the STS-102 mission. Parts and equipments. The The external storage platform on ESP-1 of the International Space Station ISS is a modified version of the integrated cargo carrier used by the space shuttles. Made from steel, ESP-1 serves as an external pallet capable of holding various ORUs crucial for maintenance and repairs aboard the ISS. These ORUs are attached to the ESP using flight releasable attachment mechanisms, FRAMs, ensuring a secure and stable connection between the platform and the stored equipment. The specific ORUs stored on the ESP-1 include the Pump Flow Control System (PFCS) and Direct Current Switching Unit (DCSU). These components are vital for regulating and managing various functions within the ISS, such as fluid flow control and electrical power distribution. The PFCS was replaced during an EVA on Expedition 55 in May 2018, highlighting the ongoing maintenance and upgrade activities conducted using ESP-1. Dimensions. The external storage platform on ESP-1 has dimensions of approximately 0.46 meters in width and 2.4 meters in length. These dimensions make ESP-1 smaller compared to other external storage platforms like ESP-2 and 3. In conclusion, the external storage platform on ESP-1 is a vital component of the International Space Station ISS. ESP-1 efficiently utilizes space while providing a secure and accessible storage location. Its installation on the port side trunnion pin of the Destiny laboratory module during the STS-102 mission marked a significant milestone in enhancing the International Space Station's capabilities for supporting long-duration space missions. ESP-1's design and functionality highlights the importance of innovative solutions for space exploration and infrastructure development in space. I hope this video on the external storage platform on ESP-1 was informative and interesting. I'll meet you in the next video with another interesting ISS module. Take care, bye.